Write the first statement. Carboxylic acids have higher boiling point. Higher boiling point than comparable aldehyde, ketones, and even alcohols. This is due to more extensive hydrogen bonding in carboxylic acid. In carboxylic acid. Okay, right here. For example, you have RC double bond O. Here you have OH. And for another carboxylic acid, another molecule of carboxylic acid is like this. So there is a hydrogen bond between both of these ends of carboxylic acid. So as you can see, there are two hydrogen bonding in one carboxylic acid. And this hydrogen bond is so strong that if you are going to evaporate the carboxylic acid, it is going to be in the form of dimer. So this is the vapor state. In vapor phase and also in aprotic solvent. In aprotic solvent. This is the structure of carboxylic acid when you have in vapor state or in aprotic state. This is known as dimer because we have two monomers of carboxylic acid which are together because of hydrogen bonding. Right, next here in vapor form. In vapor form, carboxylic acid exists in dimer. With structure as above. Okay, so this is the structure in vapor phase. Now, right next regarding the solubility of carboxylic acid. Please then. Aliphatic carboxylic acid are soluble in water. As they form hydrogen bond with water. You see here, how can they form hydrogen bond? Water is H2O, 2 hydrogen, 1 oxygen. This hydrogen could be having hydrogen bond with the carbonyl carbon of carboxylic acid like this. And here you have R. Similarly, this will also be like this. And this oxygen can also be bonded to okay, so it is having multiple hydrogen bond. All the three atoms of water molecule is in hydrogen bonding with carboxylic acid. That is why it is soluble in water. However, if I'm going to increase the number of alkyl groups, if I'm going to increase the number of atoms in alkyl group, this R group, if it is going to be larger, then the solubility is going to decrease. Why? Because this R group is what it is, not favorable for solubility. It is non-polar and not favorable for solubility. As we have written the case for alphas also. So please write solubility decreases as the number of carbon atom in alkyl chain increases. In alkyl chain increases. They have only written aliphatic carboxylic acid are soluble. So if you increase the number of carbon atom till 5 and 6, then the solubility decreases and it becomes not soluble. So benzoic acid, which is having how many carbon atoms? 7 carbon atoms, including the carboxylic acid. It is not soluble in water. So right, next point, benzoic acid. Is not soluble in water. Also, write another point regarding carboxylic acid. In general, carboxylic acids are soluble in organic solvent such as benzene, ether, alcohol, chloroform, etc. Please write this down. And after this, you are going to write chemical properties of carboxylic acid. In chemical properties, the first one is acidic character of carboxylic acid. Right, number 1. Acidic character. Now, in terms of reactions, so first of all, we'll discuss the reactions. A part in acidic character is the reactions, right? Reactions with metal and alkalis. It is going to give reaction with the active metal RCOH plus Na. This is going to give you the carboxylate ion RCOO negative, Na positive plus H2 gas is liberated. Then if you have hydroxides, for example, NaOH, then still you are going to get the same thing, RCOO negative, Na positive, but here you are going to get byproduct water. And if you have RCOOH plus NaHCO3, Then in this case, you are going to get COO negative, Na positive, plus CO2 and H2O. Write this down. So there are three parts in acidic character. First, these are the reactions. In all of these reactions, you are going to get the carboxylate ion, or you can say the salts of carboxylic acid and hydrogen, water, carbon dioxide, and water in different reactions. Okay. Next part of acidic character will be acidic strength. And after acidic strength, we are going to talk about the effect of substituents on the acidic strength. So first of all, write all of these different reactions. Write the B part, acidic strength. No. Acidic strength, it is known by the stability of conjugate base. Okay. Acidic strength is basically how easily can you liberate H plus ions. So if you are in water, not you, the carboxylic acid, COO and OH plus water. Now, in this case, if it is going to liberate the H plus, then I will be getting H3O plus, I will get the conjugate base, which is R, C double bond O, and O negative. Now, if you look at this, it is going to be a case of resonance A, double bond B, single bond C, and C with a negative charge. Now, in this case, starting from electron rich, that is negative charge, towards this bond, and this pi bond will break and become the negative charge. So you have a resonating structure like this, R, C, O negative, and double bond O. Okay. Now, due to this resonance here, this carboxylate ion is stable, and we can say that carboxylic acid can dissociate in water, and it is going to give you resonance stabilized conjugate base and the H3O plus ion. So that is why we say that carboxylic acid is acidic in nature. So please write carboxylic acid dissociates into, dissociates in water into, dissociate in water to give hydronium ion. Hydronium ion is H3O positive and resonance stabilized. And resonance stabilized carboxylate ion. Now, since this carboxylate ion is resonance stabilized, we can say that it is having acidic nature. Okay. Now, how to measure the acidity in terms of numbers? So, if you write the equilibrium for this, we have K equilibrium. It is what? The concentration of products upon the concentration of reactant. Now, concentration of product, what are the products that we have here? We have H3O plus and we have RCOO negative. The reactants are RCOOH and the concentration of water. Now, since concentration of water is a constant, we keep this water towards the left-hand side. We have K equilibrium times the concentration of water. For acids, this becomes Ka. And this is equal to what? H3O plus times RCOO negative divided by RCOOH. Listen very carefully. Listen very carefully. If it is easy to liberate H plus ion, if it is easy to liberate H plus ion, then my quantity of product will be higher because H3O plus will be higher and the carboxylic, the dissociated form of carboxylic acid will be higher. So if it is easy to liberate H plus ion, it is a stronger acid. If it is a stronger acid, it will liberate more H plus, more RCOO negative, and Ka will become high. If the numerator is high, then what becomes high? Ka is also going to be high. So right next. More dissociation means greater numerator and higher Ka and higher Ka. But Ka has very large values, 10 to the power 7, 10 to the power 8, and so on. So we don't use Ka, we use pKa. pKa is defined as the negative log of Ka. Negative log of Ka. Now, if you are having high Ka, that means the negative will be what? It will be more smaller. So please see, if Ka is high, log Ka will also be high. If log Ka is high, for example, log Ka की value of 5, तो minus log Ka क्या हो जाएगा? -5. So if log Ka is high, we can say minus of log Ka is going to be even lesser, and that is why pKa is also less. pKa is also less. तो जो range होता है pKa का, please write. If you have strong acid, for this the pKa is less than 1. For moderately strong, this is between 1 to 5. And here lies the carboxylic acid. It is somewhere around 4. Right, next point. If it is between 5 to 15, it is a weak acid. Oh, wait a second. And if it is extremely weak, it will have pKa of more than 15. So please write this down. Done, everyone. Yes, no, please tell me. वो pH होता है. That is pH, Khalil. That is pH. अगर आप देखिएगा ऑर्गेनिक केमिस्ट्री में तो जो पीके की वैल्यूज होती है दैट इज फ्रॉम -5 to 50. Okay, the complete range is there. Done everyone? Yes or no? Please tell me.
Done, sir.
Yes, done. Let me know if anyone is still writing. Write a question that is very famous. Please write. Although phenoxide ion has more number of resonating structures than carboxylate ion, still carboxylic acid is stronger acid than phenol. Why? So for this, you will more focus on the carboxylic acid, why it is stronger acid than phenol. So you will write, please see here. The main reason lies between the resonating structures that we get from carboxylic acid and the phenol. If I look at the carboxylic acid, we have R, C double bond O, O negative, the carboxylate ion. And in this case, O negative, double bond O. If I write the resonance hybrid for this, it is going to be R, C, O, O, delta negative and delta negative. In this case, negative charge. First of all, यहाँ पे आप ये लिखिएगा equivalent resonance. Because see, both of these are same structures only. But why? Because the negative charge is on oxygen atom here, the negative charge is also on oxygen atom here. So you will say that these are equivalent resonance, first of all. Equivalent resonance. And then you will say negative charge is delocalized on more negative or more electronegative oxygen atom. Okay, right, next. If you look at phenol, the phenoxide ion you write non-equivalent resonance. You will write here negative charge is delocalized on less electronegative carbon atom. Hence, it is less stable. Okay, hence it is less stable. Then you can write the last point. Since carboxylate ion is more stable than monoxide ion, carboxylic acid is more acidic than phenol. Okay, this is the complete answer. Resonating structures please बना दीजिएगा, ठीक है? Also this will come for like 2 marks. उससे ज़्यादा marks में आएगा भी नहीं ये. Conceptually it is not very tough to understand, but लिखने का काफी ज़्यादा है. ठीक है. So here you can see equivalent structure. Obviously if you have negative charge in more electronegative oxygen atom, वो ज़्यादा stable होगा because oxygen तो चाहता है मेरे पास electrons हो. Carbon is not electronegative, but still is getting negative charge, so वो ज़्यादा stable नहीं होगा. Okay. And always equivalent resonance is more stable than non-equivalent resonance. Yep, you can write therefore more stable. Please write this down quickly. Then everyone is please tell me.
1 minute, sir. Done, sir.
Okay. Now write the C part for acidic character, effect of substituent. Now right here. Acidic strength of carboxylic acid depends on the stability of conjugate base, that is carboxylate ion. So if I have, there can be two, the substituent can be either electron withdrawing group. So if we have electron withdrawing group that is attached to the carboxylate ion, carboxylate ion will be having, wait a second, not R, rather C. है ना, यहाँ पे आपके पास नेगेटिव चार्ज delocalize हो रहा है, complete negative charge. So if you have an electron withdrawing group here, this electron withdrawing group will pull the electrons and more delocalize the negative charge. So the charge density is going to decrease here. And if you have electron donating group on carbon atom, this is going to give electrons to the carbon atom and increase the electron density. So what is happening? The charge density decreases when you have electron withdrawing group. If the charge density decreases, stability increases and acidic character increases. Acidic strength increases. Acidic strength increase करने से क्या होगा? pKa कम होगा, ठीक है ना? pKa से भी रिलेटेड आ सकता है कि आप इसको pKa के ऑर्डर में लिखे, pKa के ascending order, descending order में लिखे. So always remember acidic strength is high, so pKa is going to be low. In this case, the charge density is increasing. That is why stability is decreasing. Acidic strength is decreasing. The value of pKa is going to increase in this case. So this electron withdrawing group and the electron donating group, they can be present on any carbon atom of the chain. If they are present in the chain that is having carboxylic acid, if it is present in the compound that is having carboxylic acid, then it is going to increase or decrease the acidic strength. If it is electron withdrawing group, it is going to increase the acidic strength. If it is electron donating group, then it is going to decrease the acidic strength. Okay, so what is the order of different electron withdrawing groups? Because we will look at electron withdrawing group here because it is increasing the acidic strength. So please write order of electron withdrawing group. अगर आपको याद हो halo alkane, haloarine में we did similar thing here. I think no, in alcohols we did similar thing. Chemical properties. हाँ, यहाँ पे देखिए इलेक्ट्रॉन डोनेटिंग ग्रुप, इलेक्ट्रॉन विड्रॉइंग ग्रुप फेनॉल के केस में किया था हम लोगों ने. ओके, सो जो फेनॉल के केस में इट इज वेरी सिमिलर टू इन द केस ऑफ बेंजोइक एसिड आल्सो. ठीक है, इट इज वेरी सिमिलर इन द केस ऑफ बेंजोइक एसिड आल्सो. जब आपके पास ऑर्थो और पैरा पे है, देन यू हैव टू लुक एट द मेसोमेरिक इफेक्ट. इफ इट इज एट मेटा पोजीशन, देन यू हैव टू जस्ट लुक एट द प्लस आई और माइनस आई इफेक्ट. बट हियर यू राइट order of electron withdrawing group. If there is a benzene ring attached to the carboxylic acid, then it is going to be electron withdrawing, because all the carbon atoms of benzene ring are going to be sp2 hybridized, and sp2 hybridized carbon atoms are more electronegative because it has more s character. If there is more s character, the electrons will be nearer to the nucleus, and if it is nearer to the nucleus can pull it more effectively. That means the nucleus is able to pull the electrons means the negative charge. So in phenyl, that is benzene ring. If it is benzene ring is attached to carboxylic acid, then it is going to be electron withdrawing group. But more than that, we have iodine, then we have bromine, then we have chlorine, then we have fluorine, the nitrile, followed by nitro group, and the most acidic will be CF3. Write this down.
Sir, can you scroll a little bit up?
Please write this question. Okay. Please write this. I'm just coming into. All of you wrote the question?
No, 1 minute, sir.
लिखिए जल्दी लिखिए जल्दी. Look at the structures in the first case. We have one carbon atom, CS3. Here we have double bond O and OH versus double bond O and OH. Here we have a fluorine atom also, right? CH2 and fluorine. A or B, which is going to be more acidic. Second, here we have two carbon atoms here also. Okay, so here we have double bond O and OH. We have fluorine versus double bond O and OH, fluorine. A and B, which is more acidic. The third case, we have 1, 2, 3, 4 carbon atoms. And the first one is having fluorine. So 1, 2, 4 atoms, COOH, and this is fluorine. Versus we have 1, 2, 3, 4 COOH, and in this case, 1 and 6. This carbon atom is having fluorine. A and B, which is more acidic. Fourth case में तो आपके पास बना ही हुआ है A and B, which is more acidic. So if there is electron withdrawing group, it is more acidic. Okay. So you try this question. I will give you like 2-3 minutes. Please tell the answer on the chat itself, the Zoom chat. 1 may A or B, 2 may A or B, 3 may A or B, 4 may A or B. Okay, I've got some answers. Okay, Astha, A is correct, B is correct. Oh, matlab, first is correct, second is correct, third is not correct, fourth is correct. Okay, please see here, guys. In the first case, Minashi, correct, correct. Third wala nahi aa raha hai. Okay, fine, fine. See here, guys. In the first case, first A, do we have any electron withdrawing group? No. In the B case, do we have any electron withdrawing group? Yes. So the one which is having electron withdrawing group, that is going to be more acidic. So B is more acidic in this case. Now in the second structure, A and B. In A, do we have electron withdrawing group? Yes. In B, do we have electron withdrawing group? Yes. Now if we have electron withdrawing group, then you have to look at the strength of withdrawing group. So if I look at the strength of fluorine, fluorine is going to be more electron withdrawing according to this order here than chlorine. So here A is going to be the more acidic one. Now, fourth case में same thing. Here you have it in the para position. So para position में तो आप इसको देख सकते हैं. यहाँ पे however you are going to just use the plus I and minus I because CF3 is not going to have any plus M or minus M effect. Okay, so CF3 is going to be most acidic in this case. That is A1. This is most acidic because it is not an electron withdrawing group. CS3 is not an electron withdrawing group. In the third case, do we have electron withdrawing group? Yes. In A and B, both? Yes, we have electron withdrawing group both in A and B. Are the electron withdrawing group different? No, they are same. Now, when you have same electron withdrawing group, then you will look at the position of electron withdrawing group, which is nearer to the carboxylic acid. If something is nearer to the carboxylic acid, it will be able to pull the electrons more effectively. Because it is near to the negative charge, it is going to pull the electrons more effectively. So in this case, B is going to be more acidic than A. Please write this down. So the answer is 1B, 2A, 3B, 4A. Everybody write this down. No, the acidic character is over. Write the second reaction, formation of anhydride. Second chemical property. Formation of anhydride. So if you have a carboxylic acid such as the ethanoic acid and another mole of ethanoic acid, they are going to react with each other in the presence of H plus and heat or P2O5 and heat, and water molecule is liberated. And once water molecule liberated, what do we have? This oxygen and this carbon, they form a bond. So you will have oxygen followed by another. This is carbonyl carbon. This is the carbonyl carbon. Okay, so this oxygen here, it attaches to this carbon atom here. Okay, it attaches to that carbon atom here. So we get, this is ethanoic acid. And this is ethanoic anhydride, or we also call this acetic anhydride. Okay, or acetic anhydride. Similarly, that means if you have any general case of RC double bond O, OH, if you take 2 moles of this, react this with H plus and heat, you are going to get R, C double bond O, O, C double bond O, and R. Okay, so this is the general structure of anhydride. The reactions are quite easy, so please write this down quickly. Write the third one, formation of esters. Formation of esters. For ester, you react carboxylic acid with alcohol. So let's suppose we have a general carboxylic acid RCOOH plus we have an alcohol R-OH. In acidic condition, if you add H plus, then esterification happens and you get RCOO R-. So for example, if you have COOH plus we have propanoic acid and ethanol. So in this case, you are going to get COO and you are going to get C2H5. Or you can write this as C double bond O, O, 2 carbon atoms, CH2 and CH3. I write this down, then we will look at the mechanism for this reaction. Okay, please look at the mechanism. First of all, we have the carboxylic acid. This oxygen atom, it has lone pair electrons. Okay, and in the presence of H plus, this oxygen atom is going to attack the H plus, leading to formation of R, C double bond O, H, which is having a positive charge, and here we have OH. Once you get a positive charge on oxygen atom, this carbon atom becomes too much delta positive, and hence the alcohol, that is R-OH, the oxygen atom, it is having lone pair electrons and it attacks as a nucleophile onto this carbon atom. It acts on this carbon atom, and as soon as this attacks, the carbon atom gives the pi electron to the oxygen atom because it cannot form 5 bonds, and you get R, C, OH. This OH is as it is, and here you get OR dash, and here you get OR dash. This also is having the hydrogen atom. Just a second. We get oxygen. Oxygen has a hydrogen and also an R dash. Okay, and a positive charge here. This hydrogen atom will get delta positive charge because it is connected to oxygen, which is electronegative, as well as it has positive charge. And this oxygen atom from here, this is going to attack onto this hydrogen. This type of reaction is known as proton transfer. So proton is transferring from one electronegative element to another electronegative element. Now, this will be in equilibrium and you will have R, C, here you have OH, here you will get O, and 2 hydrogen with a positive charge. And here, this hydrogen atom is going to give the electrons to oxygen and neutralizing it. So you'll get O, R dash. Now, as soon as you see that we have oxygen atom with a positive charge, and it is having 2 bonds with hydrogen, this is going to go away as water. So as soon as this is going to go away like water, oxygen atom from here it is going to give the electrons to carbon atom, forming a double bond, because carbon is losing a bond. So you will get R, C double bond O, H with a positive charge, and here you get OR dash. Now water molecule will come and it is going to abstract the H plus. H plus will give the electrons to oxygen atom, and you will get R, C double bond O, OR dash. Okay, so this is the ester. Please write this down.
Is it platinum or RT?
No, this is proton transfer. ये ना proton transfer PT. Small p, small t. Proton transfer. Not platinum. Not everyone, yes or no, please tell me.
Yes, sir, done.
Right, next. Formation of acid chlorides. Now, all the halogenating reagents such as PCl5, PCl3, and SOCl2, these can be used for getting acid chloride. So if you have R, C double bond O, and OH, if you react this with PCl5, or you react this with PCl3, or you react this with SOCl2, in all of these cases, this OH is going to be replaced by chlorine. So you'll get R, C double bond O, Cl, plus if you have PCl5, you are going to get POCl3 and HCl. If you have PCl3, same product plus S3PO3. In SOCl2 also you will get acid chloride plus SO2 and HCl. So these reactions are very similar to what we have done in the haloalkane halorine chapter. So maybe all of these reagents were used to replace the OH, but that was alcohol and this is carboxylic acid. So from alcohol, if you replace the OH with any halogen, you are going to get haloalkane. From carboxylic acid, if you replace the OH with any halogen, then you are going to get acid halide or acyl halide. And in this particular case, you are getting acid chlorides. Right, the fifth one, formation of amides.
7 minutes.
हाँ लिखिए नहीं आगे बढ़ रहे हैं. Formation of amides. Right here, treatment of carboxylic acid with ammonia gives ammonium salt. which on heating gives might. So if you have R COOH plus NH3, so NH3 is a base because it has lone pair electrons, and it is going to give you the salt of carboxylic acid as RCOO negative. Nitrogen is going to abstract the hydrogen and form NH4 positive. So this is the ammonium salt. And if you are going to heat it, it is going to liberate H2O water. So you remove one oxygen, so you will get R C double bond O. And you are going to get how many? You are removing two more hydrogens from here, so you will get NH2. So this is amide. For example, if you have 1, 2, 3 carbon atoms plus NH3, first is NH3, second is heat, then you are going to make 1, 2, 3 carbon atoms, CONH2. Or you can write it like this also. यहाँ पे लिखिए, you have an important reaction, formation of phthalimide. Formation of phthalimide. If you have benzene ring with 2 carboxylic acid group in the ortho position, and if you react this with ammonia, then you are going to get the salt on both of these carboxylic acid, COO negative, NH4 positive, COO negative, NH4 positive. Okay. Now, once you heat, water is going to be liberated, and you will be getting CONH2 from here and CONH2 here also. Once this happens, if you are going to heat it once again, and this will be very high temperature, then you are going to liberate one molecule of ammonia. So one NH3 molecule is liberated. So one hydrogen from this amide and 2 hydrogens from this amide and 1 nitrogen. So you will get another ring like this, carbon double bond O. Here also you will get carbon double bond O bonded with nitrogen and 1 hydrogen like this. This is known as phthalimide. This is the structure of phthalimide. Done, everyone? Is everyone done? जी लिख लिया आप लोगों ने. Right, next. Reduction. This is sixth. Sorry. This is sixth reaction. Reduction. So we know that carboxylic acid, when we are going to reduce, it is going to give you alcohol. Okay, it is going to give you alcohol. And please remember, we can use two reducing agent. Please write R. Right here, carboxylic acids. Are reduced to alcohols using LiAlH4 or B2H6. B2H6 is also known as diborane. So please write RCOOH the presence of LiAlH4, and you need to have acidic hydrolysis. You will get RCH2OH. This is alcohol. And also this is 1 degree alcohol. Similarly, if you have RCOOH, the presence of B2H6 and acidic hydrolysis, you are going to get RCH2OH, 1 degree alcohol. Also remember, if you have RCOOH and NaBH4, then this is not going to give you any product. Then everyone, you please tell me. लिख के इसको बताइए.
1 minute, sir.
Yeah, write it down. Right, the seventh one.
So the last one is no reaction.
No reaction. Decarboxylation. You see, if you have salt of carboxylic acid such as RCOONA, and you treat this with soda lime. Soda lime is NaOH plus calcium oxide, and heat it. You are going to get RH, that is an alkene. Can you see that if we have R plus 1 carbon atom, here we have only R carbon atoms, and you get Na2CO3. Okay. So for example, this is going to be used when you are converting carboxylic acid, simple alkene, and 1 carbon less alkene. So if you have 1, 2, 3 carbon atoms in carboxylic acid, they will give you the reaction like this. In the first step, they will give you NaOH Second step, they will give you NaOH plus calcium oxide and heat. So you are going to write, here we have 3 carbon atoms. So the alkane that we'll be getting will have only 2 carbon atoms, CS3 plus Na2CO3. NaOH plus calcium oxide in 3:1 ratio is called soda lime. All right, the 8th reaction. Hell-Volhard Zelinsky reaction. This is also known as HVZ reaction. Okay, the name is quite big, but the reaction on its own is very simple. The reaction on its own is very simple. What's the reaction? If you have any carboxylic acid with 1 alpha carbon, so you have with 1 alpha, at least 1 alpha hydrogen, CH2, C double bond OH, COOH. Okay, then you have, this is the alpha carbon. This alpha carbon contains 1 hydrogen. If you have any species that contains 1 hydrogen, the alpha carbon contains a hydrogen. Then on treatment with halogen in the presence of red phosphorus, and in the second step, hydration, you will get a halogen atom X on the alpha carbon. So hydrogen will be replaced by halogen. So please write this. Carboxylic acid having at least 1 alpha hydrogen. Carboxylic acid having at least 1 alpha hydrogen. At least 1 alpha hydrogen are halogenated at alpha position on treatment with bromine or chlorine in the red phosphorus. To give alpha halo carboxylic acid. Alpha halo carboxylic acid. So for example, you have 3 carbon atoms, COOH, Br2 red P, and H2O. Everything will be as it is. The alpha carbon is going to get bromine here. Cl2 red P, H2O. The alpha carbon is going to get chlorine. Then everyone, yes or no, please tell me.
1 minute, sir.
Technique, electrophilic aromatic substitution.
Sir, can you scroll up?
जल्दी लिखिए साहब, साथ में लिखा कीजिए ना सर, aromatic substitution. Wait a second. Staff, let me know once you're done.
Yes, sir. Done.
Okay, now you all will write with me only. Okay. In electrophilic aromatic substitution, the first thing that we have to determine is whether carboxylic acid is deactivating or activating. So carboxylic acid, it is carbon atom with a double bond O and then OH. So whenever you have carbon atom that is connected to benzene ring, so the atom that is connected to benzene ring is known as key atom. If it is connected with a electronegative atom with a double bond or a triple bond, multiple bonds, then it is going to be electron withdrawing group minus M and deactivating. Please write COOH group is deactivating and meta directing. Substitution occurs at meta position. Substitution occurs at meta position. Now it shows only two reactions, that is nitration and bromination. Please write. Number one, nitration. Conc HNO3, conc H2SO4. In the meta position, you will get NO2. In bromination, you are going to use Br2 and FeBr3. To get Br in the meta position. This is what? This is M nitro benzoic acid. This is M bromo benzoic acid. Then everyone, yes or no, please tell me. We'll write a note. Benzoic acid does not show Benzoic acid does not show Friedel-Crafts reactions as they are deactivating, and the Lewis acid used and the Lewis catalyst AlCl3 used gets bonded to the carboxyl group. Done everyone? Yes or no? Please tell me. लिख लिया आप लोगों ने?
Yes, sir.
Write these 3 questions.
So we have to write the question.
Write the question. See, right, for the first one, cyclohexanol forms cyanohedrin in good yield, but if you have 2,2,6 trimethyl cyclohexanol, it does not. So what is 2,2 trimethyl cyclohexanol? You have cyclohexanol like this. Double bond O. Second carbon is having CS3. 1, 2, 3, 4, 5, and 6 carbon atom is having CS3. So as you can see, there is a lot of steric hindrance on this carbonyl carbon. It is attached with 3 methyl groups. Okay, the alpha position has 3 methyl groups, and that is why there is steric hindrance. So you will write, since alpha position of C double bond O, that is carbonyl carbon, has 3 methyl groups. It causes a lot of steric hindrance. Therefore, nucleophile Cn negative cannot attack the carbonyl carbon. ठीक है, C double bond जहां पे भी है ना उसको carbonyl carbon लिख सकते हैं, carbonyl group. Then you have the second question. There are two NH2 groups in semi-carbazide. However, only one is involved in the formation of semi-carbozones. So write second one. What is semi-carbazide? You have NH2, NH, C double bond O, NH2. So either this NH2 could be used in the formation of semi-carbazone or this NH2. Okay, तो कौन सा use होता है? The left one is used, right one is not used. Why is the right one not used? Because in order to start the reaction, the nitrogen's lone pair, the nitrogen has to attack the carbonyl carbon of aldehyde or ketone from this lone pair. And here also we have a lone pair, but this lone pair is in resonance. NH2, NH, C, O negative, double bond NH2 positive. Okay. So now, since this nitrogen's lone pair electron, it is not localized, it is not available for the attack. Can all of you see that? Yes or no? Please tell me. आप इसको ऐसे लिखिएगा. This is your ANH2 and this is your BNH2. Okay. So you'll write here the lone pair in A, the lone pair in ANH2 is localized. ठीक है, वो एक ही जगह इधर-उधर भाग नहीं रहा, is localized and hence can attack the carbonyl group. But the BNH2 is in resonance and delocalized. Hence, cannot attack the carbonyl group. Right, the last one. When you have ester and alcohol, whenever you are preparing ester, whenever you are reacting esters, whenever you are preparing esters from carboxylic acid and alcohol, in the presence of acid, water or ester should be removed as soon as it is formed. Why is that? So you have to look at the reaction. We have RCOOH plus R-OH. I will get the ester. Now this is an equilibrium here, okay? Formation of ester. So this is an equilibrium and I'm going to get RCOO R dash plus H2O. Now please see, if I'm going to remove the product, both of these are what? Products, right? If I'm going to remove the products, then according to the Le-Chatelet principle, the system will give me more products in order to maintain the equilibrium, okay? And the reaction is going to shift towards the product. So please write the answer like this. To shift the equilibrium in forward direction, to shift the equilibrium in forward direction, ester or water should be removed as soon as it is formed. All of you done? Yes or no? Please tell me.
1 minute, sir.
Yes, sir, done.
Okay, let's start the amines chapter here only. We'll take 15-20 more minutes. And we'll start with the methods of preparation of amines. Done, guys?
Yes, sir.
नहीं लिखा अभी तक? हाँ, सैफ लिख लिया आपने?
Done, sir. Yes.
Right here. The method of preparation of amines. Right, the first method, reduction of nitro compounds. Reduction of nitro compounds. So please see. There are two methods for the reduction of nitro compounds. One can be done if you have H2 in the presence of PD, and the other can be done if you have Fe in the presence of HCl or Sn in the presence of HCl. Okay, so please think the two methods. Number one, if you have RNO2, in the presence of H2PD, instead of palladium, you can use nickel or platinum also. Okay, any catalyst. This will be in the presence of ethanol. ETOH, ethanol, the short form ETOH. Okay, and ethanol here it is used as a solvent. Area reagent nahi hai, please write this. Ethanol is a solvent, and you get R and H2. Similarly, if you have nitrobenzene also, in the presence of H2PD, you will get aniline. This is aniline. The second reagent that you can use is a reduction with Sn plus HCl or Fe plus HCl. Write a note. Reduction of nitro compounds for formation of amines is preferred as FeCl2 formed gets easily hydrolyzed to release HCl as gas. HCl as gas in the reaction. Okay, so if HCl is released as a gas, then what is going to happen? You're not going to need any mode of filtration or separation. You just get amines here. Okay, and also the HCl that has been released as a gas, it can re-react with the same nitro compound. So if you add even small amount of HCl, So you will form more and more HCl in the solution, and slowly what is going to happen? This HCl that is in the product is again going to be used as the reactant until and unless all the HCl are being used. So we'll write, and hence therefore small amount of HCl is required. Then anyone is please tell me. Done guys? लिख लिया आप लोगों ने? लिख लिया तो अगला लिखिए
Yes, sir, done.
ammonolysis and halides. Is right next. Second method of preparation. Ammonolysis of alkyne halides. Okay. We have seen this reaction in the haloalkane halorine chapter. If you have NH3, if you have ammonia, and you react this with alkyl halide, ammonia has lone pair electron. The carbon atom of alkyl halide is going to have delta positive charge because it is connected to electronegative element, that is halogen. So this is delta negative. So nitrogen is going to attack on this R. This is going to give you the NH3 R. Wait a second. You will have NH3 R. So this nitrogen atom, it has 4 bonds. If it has 4 bonds, then it will get a positive charge. And as soon as it gets positive charge, it will be attached with a X negative also. So this is substituted ammonium salt. Substituted ammonium salt. Okay. Once you get this, you can react this with NaOH. If you have R that is bonded to NH3, positive and X negative, in the presence of NaOH, you will get RNH2 plus H2O and sodium halide. Okay, but it has some multiple disadvantages. Why? Once you get this RNH2, this RNH2 can further react. So for example, if I start with like this, we have R, we have got this RNH2. Now this RNH2 can further react with RX, the haloalkane, if there is remaining haloalkane. So again, this nitrogen atom is going to attack on the R, and you are going to get R, NH, and one more R. Then further, if you have some more remaining RX, this is going to react with R, N, R, and one more R. Okay. Now still we have the lone pair on the nitrogen atom, and if we are having the lone pair on the nitrogen atom, it is still going to attack on the RX. This still attacks on the RX, and you get R, nitrogen, R, and R with a positive charge. Now the reaction is going to stop, and this is, see, this is 1 degree amine, this is 2 degree amine, this is 3 degree amine, and this is 4 degree amine, which is known as quaternary ammonium salt. This is quaternary ammonium salt. Now, please write a note. Ammonolysis is not a preferred method of preparation of amines as it gives mixture of 1 degree, 2 degree, 3 degree and quaternary ammonium salts. To get amine as major product. अगर आपको amine major product चाहिए, that means you have to keep the haloalkane in a very less quantity. That means NH3 should be in excess. To get amine as major product, NH3 should be in excess, should be in excess, should be in excess. तो कहीं भी अगर हालोअल्केन जाए तो हालोअल्केन को सिर्फ और सिर्फ अमोनिया ही दिखे, उसको 1 डिग्री 2 डिग्री या 3 डिग्री अमीन्स ना दिखे. So that for that you need to have a lot of amount of NH3 molecule present. So you will get amine as a major product. Right, next order of reactivity of haloalkane. So the best leaving group is iodine, hence Ri will be fastest, followed by RBr and followed by RCl. Okay. Fluoroalkane does not show reaction because it does not leave easily. The fluorine is not a good leaving group. Done everyone, yes or no? Please tell me. Done, guys?
Yes, sir, done.
Right, next. Reduction of nitrites. Third is reduction of nitrates. So what are the reducing agent that we can use? So obviously the reducing agent that you can use. First one is what? LiAlH4, lithium aluminium nitride. Then there is catalytic hydrogenation. Catalytic hydrogenation means what? H2 in the presence of nickel, palladium, or platinum. Another thing that you can use is sodium in the presence of Hg, that is sodium amalgam and ethanol. So the reagents that you can use is number one, LiAlH4, H2 in the presence of nickel or PT or PD. Hydrogenation, okay, catalytic hydrogenation. Third is in the presence of ethanol. All of these are going to give you what? The carbon atom will get 2 hydrogens and the nitrogen is going to get 2 hydrogens, NH2. And then everyone, yes or no, please tell me.
Done, sir.
Right, next. Reduction of amides. So for amide, you can just use LiAlH4. We have R, C double bond O, NH2 with lithium aluminium nitride. In the second step, we use water. We are going to get R, CH2, NH2. Right, a question, how will you convert ethane nitride to ethanamine? Okay. So it's very easy. You have two carbon atoms, CH3, C triple bond N, 2, CH3, CH2, NH2. So what are we going to use? H2 in the presence of nickel PD or PT. एक चीज याद रहे, IUPAC nomenclature of this is ethane nitride. But if you are going to write the common name, this is methyl cyanide. ठीक है? तो इसको क्या बोल सकते हैं? This is methyl cyanide. और ये क्या हो जाएगा आपका? This will be ethane nitride. Sorry, ethanamine. Not nitride, ethanamine. ऐसा लग रहा है आपको कि एक कार्बन इंक्रीज हो रहा है बिकॉज हियर वी हैव मिथाइल एंड हियर वी हैव ईथेन, बट ऐसा नहीं है. मिथाइल साइनाइड मींस मिथाइल में वन कार्बन एटम, साइनाइड में अनदर कार्बन एटम. सो it is having two carbon atoms and the product is also having two carbon atoms. Please write this down. There are two methods of preparation remaining for amines that we are going to do in the next class. Then everyone, yes or no, please tell me. लिख लिया आप लोगों ने?